Hello everyone. This video is on the Knewton Alta assignment for section 2.1, part 1, called Solve Equations with the Subtraction and Addition Properties of Equality. So in this video, I'm going to be going through a preview version of this particular assignment. So please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same. Alright, so I'm hoping that watching me go through these examples here will help you out in some way when you work on the assignment on your own. Alright, so here we have your assignment page. You'll have the title of the assignment up here. You have this mastery bar, which tells you, your progress, how far along you've gotten, how much you've mastered of the assignment. Then you can view all the objectives you need to complete for an assignment by clicking on this down arrow here. And it looks like for this particular assignment, there are 4 objectives. And you'll also see next to each objective, there's kind of like this circle with a star in the middle. This is showing you your progress for each objective, how far along you've gotten in, to completing that objective. Alright, and you'll see a current objective. Alright, so the objective that the question you're looking at is currently about. Alright, and then the question below is, related to that objective. And then at the bottom of every question, you should be seeing the following. You have a feedback button, which if you notice any issues with a problem, like typographical errors or just mistakes in general with the solutions or whatever, you can click on this, send some feedback to Knewton about that particular problem. Alright, you will not have this instructor cheat button. Right, this is only for me, only for instructors. Right? But you will have a more instruction button. Right, now this is, I'm going to show you, being the first assignment for this particular series of videos, I will show you this more instruction, right, what it does. If there's an objective you're having trouble with, a particular question you're having trouble with, don't guess. Because if you get things wrong, your progress, I know you don't see any progress yet, because I haven't done anything, but if you get something wrong, it's going to back your progress up a little bit, and then you'll have to answer even more questions to master the objective, master the material. So yeah, do not guess if you don't know what you're doing. Do some further reading or go here. So suppose I didn't know what I was doing. I'm in this objective, verify a solution of an equation. And we're asked, which of the given values is a solution to this equation here? Well, say I didn't know what I was doing for some reason, and I felt like I needed some extra help. I click on more instruction, and then I'll be taken to this where I was having trouble. We're on this objective again, verify a solution of an equation. Then I click on view instruction. And then it takes me to a place where there's either going to be videos to watch or reading to do with some examples. So here they have a video. I'm obviously not going to watch this video inside my own video, and then after you've done watching the video or reading the material that they provide for you, you click continue, and it keeps the instruction up. All right, it keeps the instruction it gave you, But then it asks you, a similar question to the one we saw, a question related to that objective. So now I have, is d equals negative 12 a solution to the equation 8d plus 6 equals negative 8d minus 186? And then yes, no, not enough information. Okay. So now I'll actually work on this. Right. So I'll write out the equation. I'm going to go to some paper. I'll write out the equation they gave us. Right. It was 8 times variable d plus 6 equals negative 8d minus 186. Right, and the question was, is d equals negative 12 a solution? Now, a solution is simply any value that you can replace the variables with. Right, so here the variable is only d. It's any number that you can replace the variables with to make a true statement. And an equation is true when the number on the left side is the same as the number on the right side. So you just kind of substitute, you plug it in. So here's how we check. So I'm going to replace every d I see with the number negative 12. So on the left side we have 8 times negative 12 plus 6 equals, and then the right side, negative 8 times, and again I'm replacing every d with the number negative 12. And if I were you, I'd recommend putting parentheses around what you replace. Just going to make things that much easier for you, I promise. And then minus 186. And then we simplify both sides and see, is this true? That's really the question they're asking. Right? When we plug in negative 12 for the variable, do I have a true statement? All right, so remember your order. So I'll do the left side first. Remember your order of operations. You do multiplication before addition. All right, now 8 times negative 12 would be negative 96. All right, and then you still have plus 6, and then negative 96 plus 6 would be negative 90. All right, so on the left side I have negative 90. Then on the right side, again, you do multiplication before addition or subtraction. We have negative 8 times negative 12, that'd be positive. All right, positive 96. Then minus 186. And 96 minus 186 would indeed be negative 90. Right, because 90 plus 186 would be 96. Right. So the answer to the question is yes, this is a true statement. The number on the left side of the equal sign is the same as the number on the right side after I simplified. So the answer to this question is yes. Right, check that off. D equals negative 12 is indeed a solution of this equation. Alright, so going back to the assignment, I just toggle the button yes. And then once you've entered an answer, now some of these are multiple choice, some of them you enter your own answers, but then after you enter an answer, hit submit, and it'll tell you if you're correct or incorrect. It'll be green, some green strip if you're correct, and give you some sort of, hey, way to go, your hard work is paying off type message. And if it's wrong, it'll be a red strip and give you some encouraging thing like, keep it up, keep trying. And then you'll also see an answer explanation. And here there's a video to help you explain why. Please read through the answer explanations or watch them just to make sure you understand why you got something right or why you got something wrong, and maybe you can learn from it in the future. Learn from it your mistakes for the future. Alright, so I got that one correct, and we now continue. Okay, do you see how now the objective changed, but if I look at all the objectives again, do you see how now by verify a solution of an equation, you see how there's a little, this circle is filling up? So I have made some progress. So you can actually use more instruction to keep going through the assignment if you wish. So just for this first assignment in this series of videos I'm doing, I'm going to be doing the more instruction for each question, and we'll get through the assignment that way. All right. So now I'm on the objective, solve an equation using the subtraction and addition properties of equality. So it's like, oh, I don't remember what that is. Let me see if they can instruct me on what that is. So I click on more instruction, view instruction. And now here's again a video. Again, they're not always going to be videos. Right? There may be some reading to do sometimes. And say I've watched this video, and then I go continue, and then they'll give me a question. Solve this equation. Now, solving an equation is just finding a solution, finding a number or numbers that I can replace the variable with to make a true statement. Alright, so I'll write this out, and I'll also write out what the addition and subtraction properties of equality are. Let's do that first. Alright, so the addition and subtraction properties of equality. Alright, so this is just basically if A is equal to B. Alright, so say I have two numbers that are equivalent, A and B. If you add a number to the left side, you're going to also have to add that same number to the right side to keep equivalence. Same thing with subtraction. So basically, and you've probably heard this before in previous studies about equations, right? Whatever you do to one side of the equation, you have to do to the other side to keep the equation true. So if A equals B, then A plus C, I add C to the left side to the A, I must do it to the right side as well. Equals B plus C. Also, A minus C would be equal to B minus C, right? If you subtract a number C from the left side, you must also do it to the right side. And that's all that is. That is all the addition and subtraction properties of equality are. Right. Now the equation we are given in this problem is, solve x minus 313 equals 154. Right. So what you're trying to do when you solve an equation, they're asking me to solve here. Again, you're trying to find a number or numbers that can replace the variable x here and make this a true statement. The key is going to be you're going to use the addition property of equality or the subtraction property of equality to get the variable alone on its own side, or isolate the variable. So here I have x, right? That's the only term with a variable in it. Then I have minus 313. I don't want this. So what I'm going to do is I'm going to take that left side, and to get rid of a negative number, right, like minus 313, we're going to add that's, the opposite of that number. Just add 313. And negative 313 plus 313, that'll become 0, and I'll be left with just x on the left side. All right, and then the right side, I'm doing the same thing, right? This is the addition property of equality that I'm performing. So, again, I'm adding 313 to this other side as well, and I'm just doing it so I'm lining things up. But now I've added 313 to both sides. We simplify each step. Again, the left side is just x plus 0 now, or just x, equals, and then 154 plus 313 is 467. And now that the variable is alone, there's nothing times it, nothing added to, well, except for 1. Technically it has a coefficient of 1. But there's nothing around it, so this is it. This is it. That should be our solution. And now, you should be doing, you can do this in your head or write it out on paper, but you should check your solution. Does this actually work back in the original equation? So I replace x with 467, and then you have minus 313. Is this equal to 154? And yeah, 467 minus 313 is indeed 154. So you get 154 on the left and 154 on the right. This is a true statement. So this 467 for x is indeed a solution. And that's what I'm going to enter. Now if you look back at the assignment, they already have the x equals, so I don't need to type that. I just need to type the number, 467. That was our solution. And submit. And it says, perfect, your hard work's paying off. Hooray, I got it right. And again, please read through the answer explanations. Make sure you understand things. All right, and continue on. And again, you'll see, all right, so now this is another video. Sorry, don't want to watch the video. But here's another video, and then, oh, look, continue. Here's another question, same objective. But this time we'll be subtracting. See, I have s plus 159. You want to get rid of that plus 159 by subtracting 159 from both sides. All right, so I'll write that out. Let's just take it to the other side of this paper here. So yeah, the equation we're given is s plus 159 equals 25. All right, and now I'm just going to leave this the way it is now and say, hey, I'm going to get rid of, and I want s alone, so I need to subtract 159 and do it, to both sides. Then on the left side, s plus 159 minus 159 would just be s. And then 25 minus 159 is just the opposite of 159 minus 25, which would be 134. So this is negative, right? Negative 134. Right. Yeah, and that's it. The variable is alone. So this number, if I did everything correctly, negative 134 should be a good solution. And then we can check this mentally. If I were to replace s with negative 134, negative 134 plus 159 would indeed be 25. You'd have 25 equals 25. All right, so that checks out. And that's all I'm going to enter back in the assignment, right? Again, they have the s equals already, so I just need to enter the minus 134 and submit. Hooray. All right, and then continue, and now you see how the purple has moved, that circle's filling up for that one objective. Again, let me show you here. go to all the objectives. Now we can see again the progress on each objective we've made. And it looks like, just after those couple questions we're considered halfway through that objective on solving an equation using the subtraction and addition properties of equality. All right, well now I am on the objective solve an equation that requires simplification using the subtraction and addition properties of equality. All right, so I'm going to again say I don't know what I'm doing. Go to more instruction, view instruction, and here's, now this time it's some reading with an example and another example, and then we get to a question. All right, so again, I'm not going to do the reading with you. All right, so I'll write this question out, this equation, and we'll go about solving it. Right now, the variable is n. I'm trying to find a value that I can replace n with, and even notice at the end here they have n equals. So that's what I'm trying to get. I'm trying to get n by itself equals some number that I could replace n with and make this a true statement. Alright, so the equation is this: 5 times, in parentheses, 5 times the quantity n minus 4, and then after that you have minus 4n, and then equals, and then on the other side, negative 8. Alright, so if you see any parentheses with an addition or subtraction in it, you can use what's called the distributive property to get rid of those parentheses, right? So I'm going to be multiplying this n minus 4 by 5 each term in there. So this is 5 times n minus, 5 times 4 is 20. And then you still have the minus, this minus 4n wasn't in the parentheses, so you didn't distribute to that, so that's still there, minus 4n equals negative 8. And then you do what's called combining like terms, right? You see this term with an n, 5n, this other term with an n, minus 4n. Those can go together. Those can be added or subtracted. They both have n to the first power. And you just simply combine the coefficients, combine the numbers in front. So if you have 5 of something and you subtract 4 of it, you have 1 of it, right? 5 minus 4 is 1, so there's 1n. These two put together make 1n, or just n. And then you still have this term here, this constant, this minus 20. And now the equation looks like this. The left side simplified after distributing and combining like terms. The left side simplified to n minus 20, and the right side was always, negative 8. And now I just do the addition property of equality, right? I need to just plus 20 here because it's minus 20. I want to get rid of it. Get the n by itself. Do the same thing to the other side, right? Add 20. So now on the left side I have my n by itself equals, and then negative 8 plus 20 is positive 12. Right, and there you go. Now don't forget to check it, right? Let's go back and I'll do this mentally. If n were 12, first remember you do things in parentheses first, grouping symbols. 12 minus 4 is 8. And then 5 times 8 is 40. 4 times 12, right, n is 12, is 48. You'd have 40 minus 48 is negative 8. You'd have negative 8 equals negative 8. That is true. Right? N equals 12. It does indeed work. And you can check it mentally like I just did, or write it out by hand. But as long as you're checking your solutions, you should be good. So yeah, so n equals 12. Just typing in 12, or you can punch in 12 with the thing here, but I like typing. Submit. Hooray. And then continue. Again, please read through the answer explanations. Alright, so now you see we've made some progress on that objective. Alright, now they're skipping back. It's bouncing around, making sure, keep you on your toes. But now we're back to that objective, verify a solution of an equation. Alright. Now, since I've already looked at the more instruction for this, you can do it again. Right? You can do it again. There's nothing wrong with that. You can do more instruction until you complete the entire assignment. There's nothing wrong with that. It's just I feel like the more instruction is just going to take me to the same thing here since I've already seen it. It might be something different, but I'll leave that to you to check. Alright, so I'm just going to do this myself. Right? So which of the following values, which of the given values, is a solution to the equation, negative 8d plus 2 equals negative 40d plus 2? Alright, well, right away, I mean, the first value, we got lucky here. If d were 0, negative 8 times 0 plus 2 is 0. That's 0 plus 2. Anything times 0 is 0. So the left side is 2. And so would the right side, right? Negative 40 times 0 would be 0 plus 2 would also be 2. Right? You'd have 2 equals 2. That's it. That's a true statement. 0 works. Right? So I got lucky here that the first value works. If it didn't work, if it made the statement false, like negative 3 for instance, if I plugged in negative 3 for D, you'd have 26. It'd be positive 24 plus 2 would be 26 on the left, and then 122, right? 120 plus 2 on the right. You'd have 26 equals 122. That is definitely false. The number on the left is not the same as the number on the right, so that's not a solution. But that's what you have to do. Check through the values, and 0 is the only one that works. Right? Submit. Hooray. So like I said, I've already seen the more instruction for that. Again, you can do it if you want. You can click on more instruction every single problem and get through the entire assignment that way if you wish. But if I've already seen it, if I've already done it, I'm going to skip it. Okay. Alright, so here's an objective that we haven't seen yet, right? See, there's no progress. Solve an equation involving fractions or decimals using the subtraction and addition properties of equality. Alright, so again, I haven't seen this one yet, so I'm gonna do more instruction. Why not? View instruction, and again, it'll take me to some reading or some videos. Looks like some reading here, and some examples with fractions. Here's an example with decimals, and then we continue, and I'll do the equation they gave us here. All right, so I'll write this one out, do it on paper. Solve for Q. All right, so that's Q minus 1/2 equals 5/6. All right. Now this is no different than the previous examples we've seen. You have Q minus some number equals some number, right? Just because it's a fraction doesn't mean it's not a number. It's still a number. So if I want to get Q alone, all I need to do is add, right? Because it's being subtracted right now. To undo that, I would add 1/2 and do it to both sides. So now on the left side, I have Q equals, now this is where you got to be careful. I'm going to do this off to the side. We have 5/6, and then I'm adding 1/2. Now you can't just add the numerators and add the denominators. Remember, for addition and subtraction, right, and it's only for addition and subtraction, you need to have the same denominator. You must have a common denominator. The denominators must be the same. All right, and that's key. But that's and again, that's only for addition and subtraction. Multiplication and division, the fractions you're working with do not have to have the same denominator. All right. Okay, so we look at, and again, this may seem familiar to you. I'm hoping so. I mean, you know, by this point in your life, you've seen how to add, subtract fractions. Look at the denominators. 6 and 2. You know, the least common denominator or least common multiple of 6 and 2 is 6. Right? 6 is a multiple of 6, obviously. And 2 is a multiple of 6, right? 2 times 3. So I'm going to get both these denominators to be 6. Now the first fraction, don't need to do anything. The denominator is already 6. The second fraction, I need to multiply 2 by 3. Need to multiply that denominator by 3. Now be careful. Don't just multiply the denominator by 3, because that would be 1 over 6. 1 over 6 is not the same as 1/2, right? I want the number I'm working with to be the same as 1/2. So you don't just multiply the denominator by something, you also multiply the numerator by that same number. So if I multiply the denominator by 3, I must multiply the numerator by 3. Okay, so now this becomes, 5/6 plus, and then 1/2 is the same as 3/6, right? 1 times 3 over 2 times 3. That's the same as a half. And once the denominators are the same, you can put them together. That common denominator sticks around. So 5/6 plus 3/6 is, just add the numerators, 5 plus 3. But the denominator stays the same. That common denominator stays the same in addition and subtraction. So this is 8/6. Right? Q equals 8/6. Now, of course, they're going to have you simplify. They ask us to write the fraction in reduced form, simplest form. So, do the numerator and denominator have a common factor? Well, 8 is 4 times 2. 6 is 3 times 2. Right? They have a common factor of 2, and then 2 divided by 2 is 1. Right? 2 over 2, the common factor get canceled out, become 1. And so I'm left with finally, Q equals 4/3. 1 1/3, 1.3 repeating if you're writing a decimal. But there's your solution. There's your solution. And let's check this, right? I want to check them. You can do it mentally, but I'll check by hand here, just so we can practice some more adding and subtracting fractions. If I replace Q with 4/3, right, the left side becomes 4/3 minus a half. Is this equal to 5/6? Well, if I want to subtract these two, you need a common denominator. They do not have the same denominator right now. But it's easy enough to fix, right? The least common multiple of 3 and 2 is 6. 6 is a multiple of 3, 6 is a multiple of 2. This first fraction, I'd have to multiply the denominator by 2 to get the denominator to be 6. And I would then also multiply the numerator by 2. The next fraction, the half, I'd have to multiply the denominator by 3 to get a denominator of 6. And I do the same thing to the numerator, multiply by 3. So this becomes 8/6 minus, and then 3/6, which is going to be 8 minus 3, which is 5/6. Again, that common denominator stays the way it is when you're adding and subtracting. So I do have 5/6 on the left, 5/6 on the right. This works. The value of 4/3 is the solution to this equation. Makes it true. And I'm just doing 4/3. Right? 4 divided by 3. 4/3. Wonderful. And again, please read through the answer explanations. Great. Alright, and then they're giving me another one, this time with some decimals. Now, adding and subtracting decimals is easy. I feel. Just make sure you line up the decimal point. I would do it vertically if I were you, and line up the decimal point and then add and subtract columns the way you would normally add and subtract integers. Right. So I'll write this equation out and we'll do the same stuff. So here we got b minus 0.47 equals negative 2.1. So I'm just simply, to get b alone, going to be adding 0.47, right? This is 47 hundredths, right? That's the hundredths place. And I'm doing it to this side over here, plus 0.47. Okay. So now I have b on the left equals, now when you're adding, and if one term is negative and the other one's positive, it's really subtraction. Right? So negative 2.1, plus 0.47, 2.1 is bigger than 0.47, so this is going to be a negative number. And it's actually going to be the opposite of, whatever 2.1, and I'll go 2.10, just to get both terms to the hundredths place, minus 0.47, right? Negative 2.1 plus 0.47 is just the opposite of 2.1 minus 0.47, right? As long as one term's negative, one term's positive, you're subtracting in some way. So it's going to be a negative number, and it's just the opposite of whatever 2.1 minus 0.47 is, and then you subtract again. Make sure you line up the decimal points, line up, make sure that each column represents the same decimal place. And then how would you normally subtract? 0 minus 7 I can't do, so I do some borrowing. Right? Borrow from there, make that a 0. This becomes 10. 10 minus 7 is 3 hundredths. Then we have 0 minus 4, I can't do that. Decimal place lined up. So I borrow again from this ones place. This becomes 1, then this becomes 10 again. 10 tenths, right? 10 minus 4 is 6, so I have 6 tenths. And then 1 minus 0 is 1, so we have 1.63, but again, the negative number was bigger, so this is negative 1.63. And there's your solution. Right. Now, that's one way to go about it. All right. Now, what if if you like fractions, you can change decimals to fractions very simply. I could write this as b minus, and then remember this is 47 hundredths. 47 divided by 100. That's 0.47. Equals, and then negative, and then 2.1 is 21 tenths, right? This is 21, but it ends in the tenths place. 21 divided by 10 would be 2.1. And then I add, 47 hundredths to both sides, and it's just like the previous problem where I'm working with fractions. I can't just add these the way they look, negative 21 tenths plus 47 hundredths. I can't just put those together right now. I need the same denominator. Well, it's very easy to get the denominators to be the same. I would need to just multiply this fraction here by 10 over 10. That way the denominators will both be 100. Alright, so this becomes negative, 210 divided by 100 plus 47 divided by 100. Now the denominators are the same, and we get the following. b on the left, right, equals, and then, negative 210 plus 47 would be negative 163 in the numerator. And again, that common denominator of 100 stays in the denominator. And if you want to change back to a decimal, remember dividing by 100 just means move the decimal point to the left twice. That'd be negative 1.63. Exactly what I got earlier. So I mean, both kind of verify for me that that is indeed the solution. So it's up to you. I mean, if you want to work with decimals, cool. If you remember how to change decimals to fractions, right, it's just going to be divided, some number, some integer divided by a power of 10, 10, 100, 1,000. And I think working with fractions, with denominators that are powers of 10 is just as easy as working with decimals, in my opinion. But the answer is, the solution is negative 1.63. So I enter that and submit. Wonderful. Alright, so now I've seen the more instructions for all the objectives, right? You see we've made some progress on every single objective. So from here on out, I'm just going to do the question that they give us straight away. But like I said before, right, you can click on more instruction every single time and get through the assignment with the instruction available to you. Alright, so now we're on this objective again, with the simplifying one side first and then using the addition property or subtraction property of equality. Alright, so I'll write this equation out. So we have the opposite of the quantity a minus 3, and then after that plus 2a equals negative 2. Alright, so this looks like there's no number in front, but technically, it's like having a negative 1. Whenever you see a minus sign in front of something, it's like having negative 1 times that thing. Minus 3 is technically negative 1 times 3. Right? Minus 2 here is technically negative 1 times 2. So this is negative 1 times this, so I'm distributing negative 1 over this a minus 3. So that becomes negative a, or the opposite of a, and then negative 1 times negative 3 is positive 3, right? So plus 3. And then we have the plus 2a still equals negative 2. Then combining the like terms, the terms that have a with it, negative 1a plus 2a would be positive 1a. And then you still have the plus 3 term equals negative 2, and then I'd be subtracting 3 from both sides to get the a alone. So you have a alone on the left side equals, and then negative 2 minus 3 would be more negative. That'd be negative 5. And there you go. And again, please don't forget, I'm not going to do any more of the checking because I know I'm doing things right. But, check your solution. Just make sure that, when you plug in negative 5 for a, wherever you see a, that the left side and right side are both negative 2. Right, that's a true statement. And it should be. So a equals negative 5, and submit. Alright, wonderful. Made some more progress on that objective. Alright, so now we're back to verifying a solution. So here is v equals negative 1/3, a solution of this equation. Alright, so I'll write this out. Alright. Let's get back to my paper. So the equation we're given is 9v minus 2 equals 3v, and the question is v equals negative 1/3 a solution? So I'm replacing the v's with negative 1/3. So we have 9 times negative 1/3 minus 2 equals 3 times negative 1/3. Alright, so remember this is like 9 over 1 technically. And any whole number you can put a denominator of 1 on. Same thing over here. This is like 3 over 1 times negative 1/3. And when you multiply fractions, you just multiply the numerators, multiply the denominators, and then simplify if you wish. Or you can simplify first, but this would be negative 9/3 and minus 2 equals, and then a positive times a negative is negative, and 3 times 1, 1 times 3, 3/3. Right? Again, multiplying fractions, you don't need the same denominator. You just multiply the numerators, multiply the denominators, and simplify if need be. Now here you can easily simplify. 9 divided by 3 here is 3. This is negative 3 minus 2. And then 3 divided by 3 is 1. So this is negative 1 on the other side. And then negative 3 minus 2 is negative 5 on the left, negative 1 on the right. This is a false statement. The number on the left is not the same as the number on the right. Okay, so the answer is no. All right, this is not a solution. And that's all we're asked to do. Right? The answer is no. And again, please read through the answer explanation. Alright, so same thing here. This one I'll just do mentally. Alright, I feel like this will be the, it looks like we're 3/4 of the way in. I think this will be the last question for this objective. We'll see. But just replace u with negative 1/2. Now 8 times negative 1/2 would be negative 8/2 or negative 4. And negative 4 minus 1 is negative 5. So you'd have negative 5 on the left. And 6 times negative 1/2 would be negative 6/2 or negative 3. You'd have negative 3 on the right. Negative 5 on the left, negative 3 on the right. Those aren't the same. That's a false statement. So again, we have a number that's not a solution to the equation we're given. Great. And see, once you've completed an objective, it'll tell you, hey, way to go, you completed 1 of the 4 objectives, or 2 of the 4 objectives, or whatever. And you'll see that the star is filled in now, right? Once the objective is completed. Alright, so we still have those 3 other objectives to finish. Okay, we actually saw this question already, didn't we? X minus 313 equals 154. I add 313 to both sides. Get 467 for the solution. So I'm not going to write that out again. Okay, great. And then here, a plus 294 equals negative 305. I would simply subtract 294. Negative 305 minus 294 be negative 599. So a equals negative 599. I'm sorry if I'm not writing these out. I think I've done enough on paper for you to get what's going on here. Alright, so that objective is done. Alright, so fractions, and now the fraction ones I'll do because I feel like if people have a harder time dealing with fractions, seeing more examples might be useful. So here we have n minus 5/11 equals negative 1/3. So I'd be, to get n alone, I'd be adding 5/11 to both sides. And I'll do this here so we can get the denominators to be the same pretty quickly. Yeah, so on the left side I have n. It's the right side I need to work with. The denominators are not the same. They need to be the same if I'm adding and subtracting. So a quick way to make them the same is just multiply the denominators by each other. Like multiply 3 by 11, and then I'd also have to multiply the numerator by 11. And then this fraction here I'd multiply 11 by 3 to get the denominators to both be 33. And the numerator by 3 as well, right? You can't just multiply the denominator by 3. So this is negative 11/33. That's the same thing as negative 1/3, right? Plus, and then 15/33. which is the same as 5/11ths, right? So as long as you're working with fractions that are equivalent to the original ones, you're good. Then, now that they have the same denominator, that denominator is going to be the denominator of the sum. So I'll just write a fraction with 33 in the denominator. And then you just combine the numerators. What's negative 11 plus 15? Or 15 minus 11? That'd be positive 4. And 4/33, this is 2 times 2, this is 3 times 11. There are no common factors. That's as simplified as that fraction gets, and that's as simplified as that solution gets. And you can check it. 4/33 minus 15/33 would be negative 11/33, which is reduced to negative 1/3. This is a solution if you plug it back in. It makes it true. So n equals 4 / divided by, right, 4 divided by 33, 4/33. Great. Alright, so another one with a fraction. Alright, so this one I'm just going to talk out. I feel like there's only the one left. Usually it's only like 4 questions per objective if you're getting things right. I mentioned this earlier, right? If you get questions wrong, the progress bar will back up a bit, and you'll have to answer more questions to complete it. So like I said, don't guess. Make sure you're doing things right. Check your solutions before you submit. So here I'd be subtracting 4/5. Now 5 is actually 25/5. If I multiply this is 5 over 1. Multiply the numerator and denominator by 5 to get 25/5. So this is negative 25/5 minus 4/5 would be negative 29/5. And that doesn't reduce any further. Right, so B equals negative 29/5. Great. Alright, so that objective's done. You just got one more objective to complete, and that's that with the simplifying the side, right? Alright, so this one I'm going to write out, right? The ones with the multiple steps in the simplification, probably need to write these out. Alright, so this equation, we're given the opposite, right? Negative 1 times the quantity 2/3 A minus 1/3. Then after that, plus 5/3 A equals negative 4. Now, again, this is like negative 1 out here. Negative 1 times this quantity. So I'm distributing negative 1. So this would be negative 2/3 times A plus 1/3. And then you have the plus 5/3 A equals negative 4. Now, when you combine the like terms, right, the terms with A attached, negative 2/3 plus 5/3 would be 3/3. Right, adding with the same denominator. You keep that denominator. Negative 2 plus 5 is 3. This would be 3/3 A, but 3/3 is just 1. So you have 1A, and then the plus 1/3 didn't go away. Equals. And then negative 4 is, again, negative 4 over 1. And because I know I'm going to have a denominator of 3, I'm just going to change this now, multiply the numerator and denominator by 3. So negative 4 is actually the same thing as negative 12 divided by 3, right? Negative 12/3. And then we're subtracting the 1/3 from both sides. And I've already set it up so that the denominators are the same. So I keep that denominator and then combine the numerators. Negative 12 minus 1 is negative 13. Right? So negative 13/3. And that doesn't simplify any further. Those 13 and 3 don't have a common factor. So the solution is negative 13/3. And don't forget to check it, but I'm not going to, because I know I did everything correctly, and it should work. But if I were you, though, get used to checking your solutions. But yeah, negative 13/3. Great. Alright, and based on the other objectives, I feel like there's only the one more question to complete this objective. And wow, okay, lots of simplification to do here. So I'm definitely writing this one out. Alright, so the left side, we have 6 times the quantity, 9y minus 1, then minus 10 times just 5y, then minus 3y, and that's all on the left side. Wow. Alright, on the right side we have 22, then minus 4 times the quantity 2y minus 12, then plus 8 times the quantity y minus 6. Okay, so a lot of simplification to do here. First, I'm going to do all the distributing. So 6 times this difference here. There's no distributing here because 5y, this thing in the parentheses doesn't have multiple terms. It's not adding or subtracting. And here I'm distributing. Now don't forget, you're distributing the negative 4, not just 4. And here you're distributing the positive 8 to the y minus 6. Right. So here we have, 6 times 9y is 54y. Then 6 times negative 1 is negative 6. Then I'll just multiply these, right? You're doing multiplication first before addition and subtraction. Negative 10 times 5y would be negative 50y. And we have minus 3y still. All right. Equals, and then you still have the 22 there. And then distributing the negative 4 gives me negative 8y plus 48, right? Negative 4 times negative 12, positive 48. And then distributing the 8 here gives me positive 8y. And then minus 48, right? Positive 8 times negative 6. Alright, so the right side's actually real nice. It's just 22. Because negative 8y plus 8y makes 0. And then positive 48 and negative 48 when added make 0. So really all you're left with is 22 on the left side. And then over here on the right side. On the left side, 54y minus 50y would be 4y, but then minus 3y would be 1y. So you end up with 1y after combining all the y terms. Then you still have this minus 6 term though. So we end up with this much simpler looking equation. Y minus 6 equals 22, and then to get the y alone, right, I'm adding 6 to both sides. And we end up with y on the left, and 22 plus 6, 28 on the right. And if you want, I'm not going to do it, but go ahead and plug in 28 for y everywhere. And just double check that the left side number is equal to the right side number, but it should be if I did everything correctly, and I'm pretty sure I did. So y equals 28. Fantastic. And that should be it for all the objectives. Let me just, you see the mastery bar is now at 100%. All the objectives are complete. So now when I hit continue, it'll just tell me it's over. Alright, assignment complete. Now again, this was a preview, but still, the way this was structured is the same way your assignments are going to be structured as well. Alright, so now as I said at the top of the video, the questions I saw in this video may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same. The structure is the same. So I'm hoping that watching me do these several examples for each of these objectives here and showing you how more instruction works, or I'm hoping watching me do all this here helps you out in some way when you work on this assignment and any Knewton Alta assignment on your own. Okay, and thank you very much for watching.